Hello everybody. This is a follow-up to the live lesson we did yesterday and just moving you on a bit from there. Now I know those sheets were a bit fiddly to do on the Google Drive, but you had a really good go at them, whether you used straight lines or whether you did the scribbly the method. You had a really good go, and I think the hardest thing yesterday was actually getting the sheets to work rather than doing the work itself. Okay, so let's start with a quiz. Right, I'm going to give you a second to think about these. Which of the following statements is correct? Reflection and translation are both types of transformations. Reflection is a type of transformation, translation is a type of transformation, however, reflection is not. Reflection and translation are not types of transformations. Reflection is the only type of transformation. Which one do you think is correct? Okay, hopefully you said that the top one is correct. They are both types of transformations. Remember, transformation is anything you do with a shape on a grid, whether that's flip it, move it, rotate it. We haven't mentioned rotating, but that's another type of transformation as well. Which of the following is a synonym, that means has the same meaning as the word reflect? So which of these means the word reflect? Translate, image, coordinating, or flip? Which do you think? Okay, hopefully on that one you said the last one, flip. Well done if you did. You are just flipping the shape. So you've got that mirror image. Oh, this is a long one. If vertices, that's corners, if vertices A and B were both 4 squares away from the mirror line, then which of the following statements is correct when they are reflected? Right, what I might do to start me off is I'm going to draw a mirror line. I'm going to do a vertical mirror line. A and B are both 4 squares away. Okay, 1, 2, 3, 4. A, 1, 2, oh, my mouse is playing up again. 1, 2, 3, 4 is B. They're both in the same place. I don't know if that will help, but let's have a look. Vertices C and D are 2 squares away from the mirror line. Vertices C dash and D dash are also 4 squares away from the mirror line. Vertices A dash and B dash are also 4 squares away from the mirror line. None of the above. Well, we know that if they're reflected, they've got the same names with a dash after it. So that narrows it down. And if they're 4 squares one way, they're going to be 4 squares the other way. So which one do you think? Hopefully you said the third one. A and B are also, A dash and B dash are also 4 squares away. Which of the following is correct? A mirror line is a straight vertical line. A mirror line is a straight horizontal line, which shows that both sides have exact reflective symmetry. A mirror line is a straight vertical line, which shows that both sides have exact reflective symmetry. A mirror line is a straight line, which shows that both sides have exact reflective symmetry. Which do you think? Now this was very wordy, but I'm hoping that you worked out that it's the bottom one, because this one only mentioned horizontal, this one only mentioned vertical, and this one only mentioned vertical. And we know that mirror lines can be horizontal, vertical, or even diagonal. So we shouldn't need to mention horizontal or vertical. If point A is 9 squares away from a mirror line and point B is exactly between point A and the mirror line, then where is point B dash? Oh my goodness, I think I might need a diagram. So point A is 9 squares away from the mirror line. 1, 2, 3, 4, 5, 6, 7, 8, 9. Point B is halfway. Oh, what's half of 9? It's 4.5, isn't it? 1, 2, 3, 4. It should be there. So that's point B. Then where is point B dash? Well, it's going to be opposite this B. So that will be 4.5 there in the opposite direction. So it'll be 4.5, won't it? Which is that top one, 4.5. Now that one was tricky. I hope you followed that along with me. Okay, let's just start with a bit of revision. Have a look at this isosceles trapezium, this quadrilateral. What has happened to it? Now, hopefully you can see that it's been reflected. It's not been translated. If those crosses weren't there, it could have been translated. But because the crosses are there, those colours give us a clue, because we've got purple there and purple there. And this purple is 1, 2, 3 away, and this purple is 1, 2, 3 away. So we can see rather than being translated, it's been reflected. If those coloured crosses weren't there, it could have been either, but those crosses have given it away. It's been reflected. That's what's happened to it. Each one is the same distance away from our mirror line. So this blue one is 1, 2 away, 1, 2 away, and the green one is 1, 2, 3, 4, 5, 6 away. Let's check the other side. 1, 2, 4, 5, 6 away. The black one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So they're all the same distance away from the mirror line. So some revision. What's happened? It's been reflected in that vertical mirror line. Okay, have a look at these two and tell me now the one that has not been reflected, has not. Okay, hopefully you said B. B's actually been translated, although you don't have a mirror line in translation. B's been translated because A is the one that's been flipped, and you can see that with those two corners. The sort of the corner that comes out makes almost like the roof shape, doesn't it, on that it's an irregular pentagon, isn't it? And it's the same distance away from the mirror line on each side. We've got, what have we got? 1, 2, 3.5. One, ooh, where's that going? 1, 2, 3.5. So that was shape A. Right, have another go. Which is not reflected? Which is not reflected? Hopefully you said A. A hasn't been flipped, has it? Again, it's just been moved, it's just been translated, so it's A. Okay, we've been doing quite a lot of this over this week. I want you to pause the video and write down the coordinates of the vertices of this triangle. Remember, X, then Y, horizontal, then vertical, corridor, stairs. Pause now. Okay, let's have a look. I'm going to label them A, B, and C. A has come along on the x-axis to this point, -5, and the y-axis to that point, which is 4. So A is -5, 4. Can you see we're just doing the second quadrant here? Do you remember those quadrants that we did? We're in the second quadrant. B, still -5, but here we're stopping on 2. So B is -5, 2. And C, here we've come along to -1 and up to 2. Okay, well done if you got those. Right, now look at where our reflection line is. Don't get confused here by the axes. That dotted line, that black dotted line, is our mirror line. Is it horizontal or vertical? Or vertical or horizontal? Which one is it? Tell me now. Okay, hopefully you've said vertical. I always remember it is if you look out to the sea, what's the line called that is the farthest point you can see along the sea, that straight line? It's called the horizon. And I always remember horizon, horizontal. That's where it comes from. That's the root of the word. Horizon, horizontal, and the other one's vertical. So this one is vertical. Horizon, horizontal, vertical. So that's a vertical mirror line. Okay. Right. How many squares from point A to the mirror line? Just count them for me. Remember, the mirror line's the black line. How many did you get? Did you get 7? Let's have a look. Okay, so A dash, we've come out, oh, I'm on the wrong thing, there we go. We've come out 1, 2, 3, 4, 5, 6, 7. So A dash is 7. Okay, what about B? What do you think? Hopefully you've worked out that it's actually going to be exactly the same as A, because it's just 2 below A. So that's also, let's just check, 1, 2, 3, 4, 5, 6, 7. We go through that y-axis. 1, 2, 3, 4, 5, 6, 7. It's going to be here. It's 7 away from the line. There it is. There's B dash. What about C? What would C dash be? Don't get caught on that green line, that green y-axis. Go all the way up to the mirror line. Okay, C, 1, 2, 3. So C dash, 1, 2, 3, I think would be there. There it is. Okay, pause the video and write down the new coordinates. It's all in the first quadrant, so they're all going to be positive. Right, let's have a look together. So A here, we've come out 9, and we've come out, go past the mirror line to here, 4. So X first is 9, everything's positive because it's in the first quadrant, 9, 4. B, still 9, and we've come up 2. Can you see? Can you follow that out to 2? Oh, I should label these, shouldn't I? A dash, B dash, and then C dash is up 5, and then the same as B on the y-axis, which is 2. So that's C dash. Well done if you got those. Okay, what didn't change on each of those coordinates? Can you remember what they were? Let's write them down again quite quickly. So A, if you remember, here was 9, 4. A dash, that is, 9, 4. And what's A over here? A over here is minus 5, 4. So what's not changed there? Can you see the y-axis is the same? It's a 4 on both of them. I wonder if that's a coincidence. Let's have a look at B dash. B dash was 9, 2. And what was it here? Minus 5, 2. Again, the y-axis hasn't changed. How interesting. C dash, we've come out 5 and up 2. And what was it over here? Minus 1, 2. How strange. So on all of those, the y-axis didn't change. Why do you think that is? I wonder if you can work it out. This is the reason why. When that line of reflection is vertical, remember horizontal is horizon, so when it's vertical up and down, the y stays the same. The y coordinate stays the same, because all we're doing, if you look at it, it's staying on that line along there. All the points, even though we're flipping them, they're still staying on that line. Can you see why they don't change? Yeah? So say this red sentence with me now. When the line of reflection is vertical, the y stays the same. Show me with your arm and say it again. When the line of reflection is vertical, y stays the same. Okay. Is this line of reflection vertical or horizontal? Think about the clue I gave you earlier. Okay, it's like the horizon, isn't it? It's horizontal. So what do you think the new coordinates will be if we were to reflect this shape? Now, the cat is in the way at the moment, so you might have to do a bit of imagining. I obviously put him in the wrong place. But pause the video and write down what you think the new coordinates would be. Okay, so A dash is going to be here, isn't it? 1 away from the line, which would be -5, 6. B, we've come 1, 2, 3, 4 away from the line. Oh, pussycat. 1, 2, 3, 4. It's going to be about here under the cat, which would be -5. 1, 2. Where are we? 1, 2, 3. It's 9, isn't it? -5, 9. Sorry, pussycat. Right, and C would be 1, 2, 3, 4 away. 1, 2, 3, 4. It would be there, which is -2, 9. -2, 9. So it's going to be there. Okay, so those are our new coordinates. Now, I wonder what the next question is going to be. Right, let's take it through a bit slowly. We can do this without the cat. So there's A, which was -5, 6. What about B? Tell me what B is going to be. B was -5, 9 under the pussycat. And C was -2, 9. Okay, those are our new coordinates. Okay, we want to know what didn't change on each of these coordinates. Now, do you remember when we had the vertical line of symmetry, mirror line, the vertical mirror line, the y-axis didn't change. So can you predict on a horizontal axis what's not going to change? Do you think it's the x-axis? Let's have a look. I think we can do this without using writing out all the coordinates. So if we look at A and B here, they're both on -5, and A dash and B dash are also both on -5. So the x-axis hasn't changed there. And on C, down here it's on -2, and up here it's also on -2. And of course that x-axis comes first. So the x-axis hasn't changed this time. Say the red with me. When the line of reflection is horizontal, the x stays the same. So it's the opposite to last time. So last time when it was vertical, the y stayed the same. Now it's horizontal, the x stays the same. Right. Here's a little task for you. Before reflecting the shape, write down which coordinates will change. All you need to write here is either x or y. We're reflecting on horizontal. Which one's going to change, the x or the y? That's all I need you to write down, or just say out loud. You don't need to write it down. Just say out loud which is going to change. I think it's going to be the y. Do you agree? Let's have a look. So here are the first 2 points. So we've got, oh, sorry, I was trying to get a laser and I drew instead. So we've got -6, 6, which is here. -6, 6 reflects to -6, 4. -6 isn't mentioned on the grid, but it does. And then -6, 8, which is this one, reflects to -6, 2, which is this one. So which has not changed? It's the first number in the brackets, which is the x-axis. So if I said x, and I hope you did too, and that gets it right. Let's have a look at the next 2 vertices. Okay, -5, 8, which is, here's -5, here's 8. That one reflects to -5, 2, which is this one. And then -5, 7, which is this one, reflects to -5, 3, which is this one. Again, the first number is the same in each bracket, and that first one is the x-axis. Here are the last 2. -3, 7, which is this one, reflects to -3, 3, which is this one. And then -3, 6, which is this one, reflects to -3, 4, which is this one. So all the x-axes are the same. The x-axis didn't change because we were on horizontal. Okay, can you tell me what these 4 areas on the grid are called? Can you remember they're called the 4 quadrants? This was the first quadrant where we're all positive. This was the second quadrant where we have negative x and positive y. This is the third quadrant. Tell me what we have. Negative x and negative y. And the fourth quadrant, tell me what we have. Positive x, negative y. Remember, it goes anti-clockwise. First, second, third, fourth. Okay. Now, this time, the shapes are reflected onto the x-axis. What do you think I mean by that? Have a think. What it means is there's no mirror line this time. The x-axis is our mirror line. So we don't have a separate mirror line. Can you see there's no dotted black line this time? And that's because our mirror line is our x-axis, this one, the horizontal one. So we're using that as our mirror line. Okay, so we want to reflect that pink oblong rectangle onto the x-axis. So here it is. Okay, look at the same point on each of those 2 rectangles. What are the coordinates? What's changed? What's stayed the same? Okay, so look at the point. Can you see it is reflected because it's the furthest out? What are the coordinates of both? What's changed? What's stayed the same? Okay, I'm going to call this top one A. So I'm going to call this bottom one A dash. So A has come along to -3 and is up to 4. A dash is also on -3, but it's gone down to -4. Okay, so what's changed? Well, I can see the y-axis, because it's the second number in each bracket, has gone from 4 to -4, so that's changed. But the x-axis, which is the first one, has stayed the same. -3, -3. And that's because our mirror line is horizontal. If it's horizontal, the x stays the same. Okay, write down all the coordinates of the vertices of the shape for me. Don't forget there's an internal vertice here. Okay, so don't forget that one. Off you go. Okay, hopefully you paused the video there. I didn't actually tell you to, but the cat tells you to. So let's call this one A, the one that's got the cross on it. So A, I'm going to do it over where I've got space up here. So A, -3, -2. Let's go clockwise. So B is going to be this internal one, which is -3, -3. C is going to be this one, which is -2, -3. They're all quite similar, aren't they? D will be this one, which is -2, -4. E will be this one, which is -4, -4. Very similar. Lots of patterns. And then the final one up here is F, which is -4, -2. Did you get all those? You probably didn't label them the same as I did, but hopefully you got all those. Right, so the label point we just said was -3, -2, the one that's got the cross on it. Can you see it? Here. And it reflects to -3, 2. Find this point and where is the line of reflection. So find the point first. Find the new point, -3, 2. Put your finger there. Hopefully you've come along to -3 here and then you've come up to 2, which is there. So the new point is going to be there. Okay. Where is the line of reflection? Now, this is counting the squares, isn't it, to see where we've come away from. So here we've got 1, 2, we've got 4 squares to get there. So halfway between those 4 squares is 2. So our line of reflection, can you see, it's the x-axis. Our line of reflection is that pink line. It's the x-axis. Did you get that one? Okay. And also another way you can tell that, of course, as we know, is because the x-axis stays the same. We had -3, -2, and we've still got -3 as our first digit. Our -3 is the same on both. Okay. Okay, here are all the points. We haven't got the internal angle here, so don't worry about the internal, not angle, the internal corner here. So don't worry about that one. Here are all the points labelled like we did earlier, and we got all those coordinates, didn't we? Okay, we've got a bit of a word problem now, and you've done so well today. We're nearly there. It's getting a bit tricky now because you haven't got the grid to visualise here. Triangle has coordinates of -4, -2, -4, -5, and -1, -2. When reflected upon an axis, the reflected coordinates are now 4, -2, 4, -5, 1, -2. Those colours are important, by the way. They will help you. My question is, what axis have they been reflected on? Are they reflected on the X or the Y? Now, the first thing, the clue for you here is to look at which coordinate in each set has not changed between one set and the second set. Okay, look at the pink, look at the green. What's changed? And then try and think back to which mirror line, if it was reflected horizontally or vertically, which didn't change. If you want to, draw out a quick grid, and that might help you too. We will have a look at a grid in a second. So pause and have a go. Okay, that was super tricky, so don't worry if you weren't sure. But what I can see here, immediately, if I look at -4 here and 4 here, I can immediately see that they're not the same, they're different. So, oh, my mouse. So -4 here, cat, sort this mouse out, is 4 there. They're different. So it can't be the x-axis that stayed the same. But look, -2 here is still -2 here. -5 here is still -5 here, and -2 here is still -2 here. So the y coordinate hasn't changed. The y coordinate stayed the same. So now we've got to remember, was that on a horizontal line or a vertical line? Can you remember? Try and picture it. Here it is. It was on the vertical line, the y-axis. So the y-axis was our mirror line because the y coordinate hasn't changed. So y goes with y. The y-axis, the vertical one, means the y coordinate doesn't change. Okay, so there they are. Well done if you got that. That was hard. Right, let's look at one more. And again, this is trickier. A square with the coordinates -5, 4, no colours to help us this time, -5, 2, -3, 4, and -3, 2 is reflected on an axis. When reflected, -5, 4 becomes -5, -4, and -5, 2 becomes -5, -2. So they've only told us about 2 of the reflected coordinates. We only know about 2 of the vertices. So the first thing we want to know is, where is the line of reflection? In other words, is it the x-axis or the y-axis? What do the coordinates -3, 4 and -3, 2 reflect to? And explain how you know. Oh, tricky. Pause and have a really hard think, but I am going to help you afterwards. Okay, how many of you didn't pause? Be honest, I know you guys. Okay, right, so let's have a look first of all what doesn't change. So I'm going to look straight in the second section. So -5 and -5. So it looks like the x-axis hasn't changed, and the same on the second one. So if the x coordinate, sorry, not axis, if the x coordinate hasn't changed, we must be reflecting on the x axis, which is horizontal. So I think that's horizontal, which is the x axis. I'm going to put that in brackets, x. What do the coordinates -3, 4 and -3, 2 reflect to? Okay, if it's on the same line, that horizontal line, then I know it's going to have -3 first, because that doesn't change. Now, if we've come 4 up, that's 4 away from our horizontal axis. 1, 2, 3, 4. So that means it's got to come down 4, doesn't it? And if our x-axis is 0, what's 4 below 0? I think that must be -4. Let's look at the second one. -3, that's not going to change. We know that because we're reflecting on a horizontal mirror line. What would the second coordinate, the y coordinate, be? So we've come 2 up, which means we've come 2 away from our mirror line. So we've got to go 2 away from our mirror line, the opposite direction. And if the mirror line's 0, we've got to come 2 away from that, which would be -2. Okay, and explaining how I know, well, I sort of did as I went, didn't I? Because +4 in the y is 4 away from the x. So we've got to come 4 away the opposite way, which would be -4. That was tricky, wasn't it? How did you do with that? Okay, so here's that square. And as you can see, we are reflected on the x-axis there. So we got that one right. That was the correct axis to choose. Okay, everybody, that was a tricky one. Again, there's nothing more to do today. Again, you don't need to upload anything, but I hope that you worked through all of that with me, because it is really important that we have done all that. So it's super important. Tomorrow is going to be something very different in math. So we're not doing any sort of transformation tomorrow. It's going to be different tomorrow. So well done for today. Mark the lesson as done, even if you're not uploading anything. I don't need to see just a load of notes and coordinates and things. So, but do mark it as done. And if you're not sure, you can always go back and watch bits of this again if there's a bit that confused you. I'll see you tomorrow.